Okay, hello again. This is the next video on the basics of the cash flow or CF worksheet on the TI BA2 Plus calculator. And the CF is also an extremely important part of the calculator, uh, probably about equal in importance to the TVM. It works a little bit differently. It works with just one button that allows you to enter the worksheet in which you can enter various numbers to describe a cash flow. So here's how it works. The CF also works with two other buttons, NPV and IRR, but first you have to enter in the cash flow into CF. And so you press CF to enter it. Oops, got to turn my calculator on first. All right, there we go. And CF, and if you notice, the first thing it comes up with is cash flow outlay, CFO. That's the flow at the very beginning of your cash flow. And if you had been using it before, you can say second clear work, and that clears the entire cash flow worksheet. And I'm going to show you what the other entries are in a second. And so you would enter a number in here just to illustrate. I'll put some numbers in. So 4,000. Let's put that in. That's our first cash flow. You have to hit enter, the enter button up at the top, before it is registered. And all right. So now what do we do next? So you use down arrow, and it's waiting for the next cash flow. And this is after one period. Whatever you decide what time is one period, this is the next period. And so if I put in like 560, again, I have to hit enter. And then I use an arrow key, and I move, and you see something called F01. That is a frequency or repetition value. So if that cash flow only happened once, you can leave it at 1. But if it happened more than once in a row, you can repeat it with a number here. And we'll see an example of that in a little while. So we hit down arrow again, we get to the next one. I can put in 890 and hit enter. And that's my next cash flow. And if I want to go back through what I can use the up arrow up here. That gets back to F1, C1, CFO. And if I go down arrow, I go through them again. And if I'm done, I can stop at this point. And so after all that you have in the cash flow after CFO are a sequence of numbered C's and numbered F's. C1, F1, C2, F2, C3, F3, etc. The TI BA2 Plus Pro limits you to only 24 different cash flows. But the repetition number allows us to be a bit more flexible in solving problems. Okay. Each CN is a cash flow. Each FN is a repetition number. All right. Okay, so let's go and see an example of this. Here is a basic cash flow problem that shows how to use the CF worksheet. So the problem says, what is the total present value of $1,000 paid 2 years from now, $2,000 paid 3 years from now, and $1,000 paid 4 years from now? Assume the annual effective interest is 6% throughout this time. And okay, so let's think about that. Now, first of all, let's talk about how we would do this with algebra with a cash flow equation. So in that case, we use the discount factor V, and the net present value would be 1,000 discounted 2 years, so that's V squared, plus 2,000 discounted 3 years, V cubed, plus 1,000 discounted 4 years, V to the fourth. And V is the 1 year present value factor for 6%, so 1 over 1.06. And that's easy enough to do with algebra, but it saves a little time to use the cash flow to work out this value. Okay, so let's do it. We're going to click on the CF worksheet. So first I'm going to turn my calculator on. There it's on. And we're going to click CF, and it asks for CFO. Okay, so let's look at this expression a little bit. It has a few missing terms. So in particular, if you think about it as a polynomial, it has no constant term. So it's 0 times 1 plus also no v term, 0 times v, plus 1,000 times v squared plus 2,000 times v cubed plus 1,000 times v to the fourth. So that's a polynomial with all powers shown and 0 coefficients on the first two. And to enter it in the cash value worksheet, you do need to know where the 0 payments occur. You know exactly, the payments have to be exactly the same time period apart. So looking at it from this point of view, CFO should be 0. 0 is the coefficient of 1. That's what's paid today, nothing. And so we're going to hit enter there and then go down to C1. C1 should be 0 too. There's no coefficient of V. So we're going to hit enter on that. And it'll ask me how many times. Well, it's only one time in this cash flow. So we go on to C2, and that's going to be 1,000. And you have to hit enter for it to go in, by the way. Don't forget that. That's a common thing to just go on to the next one. And F2 is 1, only occurs once. And C3 will be 2,000. So I'll click in 2,000, enter. And that only occurs once. The last one, C4, is 1,000. Enter. And everything's set now. We have that all set. So if you can see what the buttons are, we left all the F1s equal to 1. And the cash flow is really entered as the coefficients of this polynomial. So if you set it up in that framework, you can just read off what the right cash flows are as you enter it in CF. Okay, now to actually figure out net present value, there's a button here, and you have to remember that NPV stands for net present value. And it'll ask you for the interest rate. This is not a compute, this is only an enter. The calculator tells you to enter it. And you look through the problem and you see right here 6% is the interest rate. So we say 6, enter. So the interest rate is entered as a percentage. Now you have to go down, and there's where NPV is. And this one you see on the calculator, it says compute. So in order it doesn't tell you the value yet. You have to actually ask it to compute it. So if we say press the compute button, there's our answer. So you have to say down and then compute to produce NPV equals $3,361.33 rounding. Okay. Now there actually is net future value. That you can actually figure out yourself because there's a formula for net future value. Net future value is just the growth factor to the number of years or the number of periods of the cash flow, which in this case is 4 years. So 1.06 to the fourth times net present value. That's easy enough to do by yourself, but the calculator does it too. You have to say compute, and there it is, $4,243.60. So that's kind of convenient that that's there all in the NPV button. And we'll actually see some more later on use of this. Okay, now here's the second problem. This is going to be a project comparison. So project 1 requires investments of 10,000 at time 0 and 5,000 at time 1. And it is predicted to return 2,000 at time 3 and 6,000 at time 4, 5, and 6. So you have a little bit of investment at time 0 and 1, and then you get return at times 3, 4, 5, and 6. Okay. So project 2 requires an investment of $6,000 at time 0, and it will return $3,500 according to forecasts at time 1 and $5,000 at time n. At 4% interest, the net present values of both projects are equal. And that's enough to give you a condition to tell you what is n. So that's what the problem is. Figure out what n is. And let's write out the standard cash value equation. So for project 1, the net present value, you have negative 10,000 at t equals 0. So negative 10,000, you have to invest 5,000 at t equals 1. So it's minus 5,000 v. And that's the negative parts, and then the returns are 2,000 times v cubed, and then 6,000 times v to the 4th, v to the 5th, and v to the 6th, which you can factor out like that. And now project 2, you look at project 2, you have an investment of 6,000 at time 0, and you return 3,500 at time 1 and at time n. So project 2's net present value, which should be equal to the first, is minus 6,000 plus 3,500 times v plus 5,000 times v to the nth power. And so there's an equation that we can solve for n. The issue is how to solve for n. And you can actually do it with algebra as well. You would just move all the terms to one side except for n, and we will do that. So put 5,000 v to the n by itself and add 6,000 and subtract 3,500 v, and you're going to get, add 6,000 and negative 10,000, you get negative 4,000. Subtract 3,500 from negative 5,000, you get negative 8,500. Then all the other terms are the same, and that should be equal to 5,000 v to the n. And all we have to do now is plug in v equal to 1.04 to the minus 1, and you could solve for n. But we're going to do it with the cash flow worksheet. There are fewer buttons if you do it that way. So if you look at, we have the polynomial here. So the first thing we're going to do is figure out the net present value of the right-hand side. So let's go to CF and make sure we clear it. So second clear, because we were just using it. And we're going to put in 4,000 minus, and that goes in for CFO. And the next one is 8,500 negative. That goes in for C1. F1 is 1. C2 is 0. If you notice, there's no v squared term. You have to pay attention to that because you have to get the time right. If you don't put C2 equal to 0, it's going to assume that all the other payments were 1 year earlier than they actually are. So we're going to put C2 equal to 0, and F2 is 1, and C3 is 2,000. F3 is 1. And C4 is 6,000, but we also notice that we could just keep going, and C5 is 6,000 and C6 is 6,000. But here's where the F button comes in. I can say repeat that for the next 3 periods. So we're going to put a 3 there. And that repeats the 6,000 3 times at the end. So now you can check that we have it all entered in correctly here. Okay, minus 8,500 and minus 4,000. So there's our cash flow. And to figure out the net present value, we're going to go to net present value, set the interest rate equal to 4, go down, and ask it to compute it. And there it is, $4,407.19. Okay, now how do we use that? And didn't write it out here, but this 4407.19 is equal to 5,000 v to the n. So that is actually a TVM equation. That's saying a future value of 5,000 is equivalent to a present value of 4407.19. So if I want to use this here, I'm going to hit clear. So when you hit clear, it takes you out of the CF worksheet and it leaves the number that you were looking at right there on the screen. And I'm going to make that negative and put that in for present value. And then 5,000, we're going to put in for future value. So here's what we're doing. So I cleared, changed the sign, put that in as present value, and I put 5,000 as future value. The interest rate is 4, and that has everything I need to use the TVM to calculate N, which is what we're looking for. So if I say compute N, there it is, 3.217699, and that is the answer to our problem. The 5,000 should be paid at 3.218 years after the investment in Project 2 for them to have the same net present value at 4%. And that's how that problem works, and it was convenient to use the CF worksheet to do this. Okay. One last thing in this video. Here is the general cash flow equation in the CF worksheet. So the net present value will be equal to the CFO, the first value at the beginning of the cash flow. And then if C1 is repeated F1 times, it's C1 times V plus C1 times V squared plus dot 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 plus C1 times V to the F1. You can factor that all out. And then the next different cash flow, C2, well, that is already discounted by F1 periods. And then if it's repeated F2 times, you put in the same factor, V plus V squared plus dot 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 plus V to the F2. And then you just keep going like that. The next one, C3, has been discounted by F1 plus F2 periods. And if it's repeated F3 times, you have to add up the corresponding factors of V. And V will be equal to 1 plus the interest rate that you specify as a percentage divided by 100 to the -1 power. So that's it. That's the cash flow equation. And a couple of last little details. Let's say you put in a complicated cash flow with a lot of different terms, and suddenly you realize you wanted to add one in the middle, or you forgot one. There are ways to do that. So they use second insert and second delete. So, so for instance, if I go to my cash flow, and let's say I realize that that after the 2000, there was another year where the cash flow was 3,000. So I go before the 6,000 and I say second insert, and then I type 3,000 and hit enter. Okay, and now you can see that the 6,000 has been pushed off to C5, and it still has F5 equal to 3, and the 3,000 is in the middle, and the 2,000 is before it. So that's what the insert button does. If I want to delete that 3,000, I go to it and I say second delete, and there it is. And that's how you can adjust your cash flow. All right, that's it for this unit. Thanks for listening, and try out these buttons. Really get used to it, get to the feel and the understanding of how this works. They're very powerful worksheets on this calculator, specialized to financial calculations. Okay, see you next time.